Okay guys, this is lesson 1.2, how do we combine quantities when using variables. So if you notice, the aim is the same as yesterday because we're kind of talking about similar things. In example 1, it says add and subtract to rewrite the expression in equivalent form. So we are going to do that. Remember to write your notes on the right side, and on the left side, listen for anything I say is a common misconception or common mistake, and add it on that left side of the paper next to the example. Okay. So you've definitely seen and done this before. So the thing we have to look out for here is, first of all, the sign in between. So in between I see a plus sign. That means that I am adding whatever is in this expression with whatever's in this expression. If I didn't see any sign at all, that would mean that I would be multiplying. Or if I saw a negative sign or a division sign, that would tell me the operation. But this is a plus sign. So a plus sign really tells me that if there is nothing else in front of this parenthesis, then I can really just drop all the parentheses. So I'm going to rewrite this without any of the parentheses. Because essentially what this means is that I am adding x cubed, I'm adding x squared, I'm adding 6x, and I'm adding negative 12. And when I add things, the signs don't change. So now what I'm going to do is look for what we call like terms. Like terms mean that the variable is the same and the exponent is the same. So for example, 2x cubed would be like terms with x cubed because they have the same variable x and the same exponent cubed. Okay? It doesn't matter that the first one has 2 in front and this one doesn't have any number in front. Remember that if you don't see any number in front like here, it's really just a 1 in front. So first thing I'm going to do is I'm going to add those things. So I am only going to add the coefficients. Think of it this way. Here I have 2 of these x cubes, and then I'm adding another one of those x cubes. So now I have 3 total of x cubed. Okay, I'm going to keep looking for like terms. Let's see, negative 6x squared. Negative 6x squared and x squared are like terms because, again, they both have the same variable with the same exponent. So negative 6 plus 1. So remember, I'm only really adding and subtracting the coefficients. Negative 6 plus 1 gives me negative 5, and the variable and exponent stays the same. I'm going to keep going with this. Negative 7x, positive 6x. They are like terms, so I'm going to combine the coefficients. Negative 7 plus 6 gives me negative 1x. And then lastly, we have negative 2 and negative 12. Negative 2 minus 12 is negative 14. Okay, so here is my expression. I don't need to put this 1 in front of the x, but it is okay to leave it that way. One thing I want you to notice about the way the expression is written. Generally, we want to write expressions so that the highest exponent is first, and then the exponent decreases from there. So the highest exponent is 3, and then we have the exponent of 2, and then we have the exponent of 1, and then we don't have an x with the 14, but remember, it's the same as having like x to the 0. So all of the exponents are decreasing, 3, 2, 1, 0. That's how we like to write our polynomials. Okay, next example. Same thing, we're going to rewrite the expression in equivalent form. One thing I notice here is that there is a negative sign in between. Another thing I notice is that this second expression is not written in the order that we just said we like to write them in, where it's the largest exponent and then it goes descending order from there. That's okay. We don't have to write it that way until the very end when we are like submitting our solution. Okay, so first thing I'm going to do is I'm going to take care of this negative sign in between. The only way I can get rid of these parentheses is by what we call distributing that negative sign. So I'm going to take this negative sign, I'm going to apply it to everything in that second expression. So I'm going to rewrite the first expression without parentheses because we are taking care of the negative sign in between, so we can drop the parentheses. So it becomes negative 4, and then a negative becomes positive x, and a negative becomes positive x cubed. Now we can combine like terms. First thing I see, x cubed and x cubed is 2x cubed. Next thing I see is 2x squared. I don't see any other x squareds, so there are no like terms, so I'm just going to write that next. So I'm going again in descending order of exponents. So I started with cubed, now I have squared. The next one would just be the ones with the x to the first. So that would be negative 3x and positive x, which is negative 2x. And then lastly, we have negative 1 minus 4, which is negative 5. Okay, let's go on to our next example. Okay, example number 3. Okay, so now if you notice in the next example, example 3, we're going to multiply or divide to rewrite the expression in equivalent form. So I don't see any addition or subtraction. I see a fraction bar, which indicates division here. And I see there's multiplication going on between the 10 and the 8 to the 7th, and between the 2 and the 8 to the 4th. So the way that we're going to do this is we are just going to divide things that are the same. So 10 and 2 are both numbers. I'm going to divide them. 10 divided by 2 is 5. Now, where does the 5 go? Does it go on the top or the bottom of the fraction? That's what we have to think about. I just put it on the top. Well, I put it on the top because 10 divided by 2 is 5. So that means the 5 goes on the top. If it was 1/5, then the 5 would go on the bottom. So think about it this way. Wherever the bigger number is, so like the 10 is bigger, wherever the bigger number is, that's where the remainder is going to go. So if it were 2 over 10, well, the bigger number is on the bottom, so the 5 will go on the bottom and a 1 would go on the top. So technically there's a 1 down there. Now we're going to do the 8 to the 7th and the 8 to the 4th. When I divide variables, I subtract their exponents. So I'm going to show you on the side here. 8 to the 7th divided by 8 to the 4th means 8 to the 7 minus 4 power, which is 8 to the 3rd power. Again, now where do I put it? Do I put it on the top or bottom of the fraction? Think of it the same way. Wherever the bigger exponent is, that tells me where to put it. So since the bigger exponent is 7, the remainder is going to go wherever that 8 to the 7th was, which was the top. So I'm going to put my 8 to the 3rd up there. Another way of thinking of it is 8 to the 7th means there's 7 8s. 1, 2, 3, 4, 5, 6, 7. 8 to the 4th means there's 4 8s. 1, 2, 3, 4. So I can think of this as dividing out a's. So I get rid of this a with this one with this one, this guy with this guy, and this guy with this guy. Now I have 3 of them left on the top. That's how I got 8 cubed. Whenever I just have a 1 in the denominator, I don't have to write it there. So this is the same as 5a cubed. Okay, we have one more example, but this example is 2 parts. So example number 4 says use the 0 rule to write the expression in an equivalent form. Okay, so hold on one. Okay, so I lied about 2 things. One thing is that this example 4, although it does have 2 parts, we are actually doing a different problem. We are rewriting with positive exponents. So we're going to use these 2 examples to rewrite with positive exponents, and we actually have one more example after this one, so bear with me. Okay, so I notice here that this is y to the negative 4th power. You may or may not have seen negative exponents before. What a negative exponent means is it actually means that it's the reciprocal of that variable raised to that exponent. So for example, y to the negative 4th really means 1 over y to the positive 4th. So we take the variable, we flip it or use the reciprocal, and then we keep that power the same, but now we make the power positive. So if you ever want to write a power as negative, like x to the 3rd power, let's say I want to write it as a negative exponent, I would just flip the fraction. 1 over x to the negative third, these are equivalent. So it works both ways. So we just did this part. Now we're going to see in part B, we're going to see some negative exponents pop up. But we want to write it with positive exponents. So let's get started. First thing we're going to do is we're going to look at the 42 and the 15 because we can divide those. So there's a few ways you can do this. You can divide 42 and 15 by a number that is a factor of both of them, or you can use your calculator. Your calculator is very good at helping you with this. So in your calculator, you do 42 divided by 15. Now this is if you have a graphing calculator. So what you'll get is 2.8. But now if you press the math button on the left side, and you press number 1 for frac or fraction, and press enter, it gives you 14 over 5. So that means that 42 over 15 reduces to 14 over 5. So it just reduced our fraction for us. The next thing we're going to do is we're going to simplify the 8 to the 9th and the 8 to the 12th. We're going to divide those. So think about it this way. How many numbers apart are 9 and 12? So 9 and 12 are 3 numbers apart. Now we have to make the decision of where to put the 8 to the third. Do we put it on the top or do we put it on the bottom? If you recall from our last example, we put the what's left or the remainder wherever the bigger number was. So since the 8 to the 12th is bigger than 8 to the 9th, the leftover, the 3 leftover 8s are going to go on the bottom. Now, we have b to the third and b to the third. When we divide variables, remember we subtract their exponents. So this would be b to the third divided by b to the third is the same as b to the 3 minus 3, which is b to the 0. Okay, b to the 0. This is kind of tricky. First of all, where would we put it? Second of all, what does that even mean? Well, b to the 0, or anything to the 0 power, is actually just equivalent to the number 1. And in this fraction, because we already have things on the top and the bottom, it doesn't actually matter where we put the 1. If the 14 wasn't on the top, then we would have to put 1 as kind of like a placeholder on the top to indicate that the 5 and the 8 to the third are actually in the bottom or the denominator. But since we already have 14 on top, we don't have to write the 1 in there. Now I want us to think about for a second another way to write this. So 14 over 5. I could write this a cubed on the top, but if I switch its position from the bottom to the top, I'm going to have to negate it. So if I write it on the top, it's going to have to be with a negative third power. These are equivalent to each other. Since the directions clearly say with a positive exponent, this guy's the one I'm going to take. So keep in mind, again, that we know where to put things, meaning the top or the bottom, if we look at where the bigger number was. So the 12 was bigger than the 9, so that means the remainder went on the bottom. Okay, guys, we have one more example, which has 2 parts, but this is pretty quick. Use the 0 rule to rewrite the expression in equivalent form. Well, this is what we just talked about, when 0 is an exponent. So here we have 4 times x to the 0 power. 4 times x to the 0 power. So these 2 examples, common misconceptions come up all the time. So x to the 0 power, we just said anything to the 0 power is 1. So this becomes 4 times 1, which is just 4. Now for the second part, part B, now the 4x is all in parentheses. So what happens is people tend to only apply the 0 to the variable. So here's what would happen for a common misconception. So we would leave the 4 there, would do x to the 0 power, they would get 4 times 1, and they would get 4, making these 2 answers the same. But that is not the case. What we're doing here is we're raising this whole thing to the 0 power. and anything raised to the 0 power is 1. So 4x all to the 0 power is actually just equivalent to 1. Okay, so make sure you wrote in some of those common misconceptions and mistakes, and make sure you fill out your reflection section with some of these rules of exponents that we've learned. And if you have any questions, fill that in also in the reflection section. Okay, guys, see you tomorrow.